Hello and welcome to this Impact Revit webinar. My name is Desi and I'm a part of Impact Revit team in StruSoft. I'm connecting with you from Aalborg, Denmark, and I'm going to be your host for today. This is Precast Detailing and Impact Part 3 webinar, and we have already been through modeling of beam columns and Holocaust. The picture that you see here above shows you the building that we got out of it, the structure. Then we went and built on some walls and slabs in part 2, both solid and sandwich walls. So if you're interested in this type of elements, go and see the recordings. They are on our StruSoft YouTube channel. Now we're going to work on double wall, form slab, and linked elements, and we're going to do a structure on the sides of here in the building. And today, what you can expect is that we are going to solve some very, very typical challenges when doing detailing in Revit. So, how impact helps you when detailing double walls? It's the main question today, and I'm going to demonstrate you smart functionalities for solving corners, solving the priority of panels. Then when we do openings, we can see how we can automatically add these end stops around the openings as well as reinforcement. And then when we move further to the form slabs, we're going to see some recesses that impact can do, and I'm going to show you how to also insert end stops both on edges and around the holes in your form slab design. A typical challenge when doing double walls, that could be a detail like this. That's the T connection. We have a specially developed functionality for that. I'm going to show you how with several clicks of the mouse you can add reinforcement, recesses in both walls, as well as gap in the wall. So how to do it? We're going to test that today and show it with the impacts. And last but not least, we're going to draw linked element. In this case, I've chosen a staircase. We're going to save the elements, make shop drawings, and preview the elements in Impact Project Manager, which is the central tool when doing impact design. Now, let's get started. We're going to jump to Revit, and here is the Revit file which I'm going to build on today. In order to get the session to go a little bit more smoothly, I've already drawn some model lines that we're gonna go after when drawing the double walls. And yeah, we're gonna start with drawing double walls, and the first thing to do when drawing a double walls is going to the falling menu, where we have concentrated, specially developed features, functionalities that help you do the double wall design. So the first thing you need to do is to activate the draw double wall command, and here you get your definition name, the location of the definition in your impact database, and take a notice that already here you can decide the gap between the walls. In this case, I'm gonna say 10 millimeters, and pay attention that you can decide the priority of the panels that are running on the corners. So you can preview the dynamic picture is actually previewing your settings here. If it's option 1 or option 2 you use, you can also already now add an end stop if that's something you know you're going to need, and decide the distance between left and right. But end stops is something we're doing a little bit later. Let's start with drawing the double walls, right? You can draw both in 3D or in a structural plan. I'm gonna try with the 3D now. And Let's see if I say like this. Actually, I want the model line to be inside the structure, so I'm gonna go with the finish face interior stairs like this. And I'm going to draw 3 quite long double walls with the purpose of going later and using the split tool that we have in Impact. What the Impact is doing right now is taking reference in your double wall definition and adding as much components as possible, as much components as are predefined in the Impact definition. That would be lattice girders, lifts, and bracing. And Impact just came with the warning saying there is no lift defined with this mass of the wall, and that's clearly true because the walls now they are quite long. We need to split them in a while. But before drawing it, I want also to draw the 3 walls here that later I'm going to use to make a T connection. So let's see if this is going to work for me. So I say 3 small double walls running by the column that I'm going to use later to demonstrate the T connection functionality. Pressing on escape and Impact is doing the same as we saw before, inserting components in our design. So let's take a look at this. Let's see how it looks. A good thing here is to go into the parts visibility. So yeah, we have some good looking corners in here. The lattice girders are inserted. If you go on wireframe, we can see. And for these walls, we also have automatically inserted um, lift families according to our Impact definition. Okay, we need to split the walls, and I'm going to use my reference lines in here, reference planes. I'm going to activate the split wall command, split double wall command, and I'm going to start with this long wall here. Select the wall, press on escape, and then Impact says that we need to pick the location for splitting. I don't see that Impact is working, so I guess I did something wrong, but let's try again. So what we're gonna do is first select the wall. Yes, and let's see what Impact says. You can always orientate yourself by looking here in the lower left corner. I guess you're already used to that by Revit, but now I can see something is happening, and it says pick location, and I'm gonna pick those 3 reference lines. It actually doesn't matter if you clicked on the wall or just in here. Impact is just gonna split on the axis. On the, in this case, could be the, must be the x-axis. Okay, so now we have selected the 3 points where we want to split. I press on escape on my keyboard, and we agreed on 10 millimeter gap. So let's see how it looks. We can follow actually what happens here on the 3D view. Impact is updating the lifts, and that's clearly because now we have walls that are way shorter, right? And we're gonna get lifts inserted also in our walls. You can see already here we have some lift families inserted. and also here. Yes, and we need to split the gable walls. It's the same procedure. Activating split double wall command, select the wall, press on um, the D in my case. That's the reference plane. I'm gonna do two symmetric gables. And here I'm gonna press on escape and the 6 millimeter gap so we can follow it here. Wall is being splitted. So we're about to get yeah, some pretty good looking uh, double walls here. We need to do the cable on this side. So I'm gonna say split double wall, select the wall, and now impact is going to say that we need to select the location. I'm going to select the D reference plane, and when we press on OK, components will be inserted in my wall like this. And let's see what happens. We have this double walls now drawn on my project. So long so good. So long so good. We have the double walls, and you can see if we go into the wireframe sim, lattice girders are red, and this there is a meaning behind it. I'm gonna explain that a little bit later why it is. It's a warning from impact. I'm gonna look at the warning a little bit later. Now we need to solve this T connection, and in order to do it, I'm gonna go into right here. I'm gonna use the 3D view. In order to solve the connection, I'm going to go to connect wall command, activate as an impact says select double walls, right? So I'm going to cross select those two walls in here. And here it is, the command that I talked in the start is a special command that helps you actually insert the recess on right, left side of slit. It's pretty much a lot of options, right? So I think in this case it's gonna be the left side. I'm gonna do recesses from the inside, and you can insert a hole that's in this wall. It's the hole in here that goes some distance from top or bottom, or what is new in Q1 is actually that this value can also be 0 if we've heard some of you want to actually make the hole from top to bottom. That's a news from Q1 release that it can also be 0 now. And what you can do is insert a reinforcement going all the way through the connection. And take a look at the dynamic picture again. It just shows you your settings. So in this case, I'm gonna just change the anchorage and the width. I say okay, and impact is working now on the background. It's inserting the components that I defined, moving some lattice girders that you can see here that is standing in the way. And here how it looks, that's my connection. Let's take a look at it. If we go to shaded, the left has moved, some lattice girder has moved. Can we go to wireframe? Oh, it's not a good idea. Here, probably that's the best we can do in the 3D here. We can see the reinforcement is inserted. So yeah, that's you can see several clicks of the mouse and we have all those components inserting, including the holes to 200 millimeter from bottom and top. And remember, from Q1 release, we opened also that this hole can go all the way up. Let's do the same for the other side in here. It's basically the same procedure. You say connect wall, you cross select the two walls, pressing finish, and that must be the right side. This time I want to show the hole in the shop drawing. You see some settings go already now from the modeling to the shop drawing creation. I want reinforcement, and here I think it was 600, and what did we say here? 150. Yeah, let's try with that. Press OK, and Impact is doing the hard work for us. Adjusting the components, and here it is. We have two T connections off in a couple of seconds. So that's great. That's awesome. We can now go further, and I think now I want to talk about the corners. If you remember from the start, here I'm going to go to the level 1 structural plan. I'm going to go to parts just to make it easier for you to see. I'm somewhere around here. Yeah. So if you remember in the start, we could predefine which panel goes by when modeling the panel walls in the corners, the double walls and the corners of them. But if there's changes going on in the project, you want to edit it, you have the possibility. You need to go to this switch priority of joint command, right? So you press it and you can select two panels, press and finish, and it just switches. Impact is taking the other panel, the vertical, and it goes by this one. And what happened is that's not only this a minor change in the geometry, but also Impact is adjusting the reinforcement for you. So if you have mesh or reinforcement and you predefine some cover, it will be adjusted by Impact. And the lattice girder will also be adjusted. Now this one is red, right? We're gonna go to explain why this is happening in a while. But one thing at a time, we need to take the other joint, the switch priority of joint again, and we need to take the other panels. Just to demonstrate it again, we say finish, and here it's the vertical going by. So doing it one panel at a time, or you can cross select all of them and go to initial position. And Impact is not going to edit only the geometry, but also all the components around. Now this one is black again. We're going to see why in a while. Yes, so defining priorities either in the draw double wall command, or later on you have possibility with switch priority of joint command. Pretty smart one, makes your design flexible and fast. Yes, okay. I think we're there where we can solve the mystery of why some lattice girders on the edges are colored in red. And this is, this is primarily because of your settings in the definition. Everything that is drawn by Impact takes reference in the definition of the element. And if you go into the double wall definition, you can see that we've set some spacing for the girders, in my case 150 between, but also I've said that my girders need to be minimum 250 from the edge and maximum of 300. So that's my setting. And if by drawing the double wall and the families, this distances of 250 and 300 are um, not kept, then Impact is going to send a warning by coloring this lattice girder in red. And then it's up to you to take actions. If it's important in your design, you can go and edit the placement of the lattice girders. We're going to see how we do it right now. Or you can just leave it as it is. It's just important that you get the warning. So why this is red? Let's go to a functionality called um, edit lattice girders. It's this one in here. So you take you press on edit lattice girders and you select the wall. Impact is going to scan the wall for you, and we're going to show a picture with the um, showing you the distances for yeah, for this double wall. So you can see this one is red in here because the distance is not kept. When drawing the element, you have a 310 millimeters instead of 300 to the edge. Now, in a lot of cases, probably say, okay, that's not much when we talk about this scale of elements. But yeah, you can take action about it, or you can just leave it as a warning. If you take this row in here, you can say, let's scan it. And this is okay because our lattice girders are 250 from the edge, so everything works fine. But you can, if you go and erase, that's one thing you can do with this functionality. You can go and erase, press on escape. Now you have this lattice girder in red, marked in red, because this is not okay according to our double wall definition. That's more than 300 as we have set up. You can move it, you can take control over it and move it along, right? Press on escape. Or you can take a new and add a new lattice girder. It's the newly added lattice girder. It's again the same family as you've defined in the definition, the same lattice girder family. So you can go and play a little bit with this one. It's a really good tool. You can go and measure and add it on precisely on this area, 250 to 300, according to in this case particular definition, or you can just leave it as it is. Now it's yeah, 5 millimeters ahead, so we say okay, we're not going that in detail. That's probably part of the tolerance. For me, it's important to show you that it's a pretty good tool that you have here. Editing the lattice girders, you can move, you can add new, and you can delete lattice girders. So go and use it in case you need to make changes with your lattice girders. Okay, and the last thing we need to do here when talk double walls is some openings. I want to demonstrate the drawing of openings in double wall. And for drawing openings in double walls, we're gonna use the customize tool. That's the draw opening in the folding menu for double wall. We strongly advise our users to use the customized functionalities as this is how to say as a reason behind. And if you see in here in the draw opening command, we have customized it so that you can draw a window or door hole, but you can just as well draw a rectangular hole and make some hole there and or a cutout. So if I start with the window opening, I'll just make it like this. You can already go now and add an end stop to your opening. So it's going to be adjusted to the geometry of your opening here. in the double wall. You can make material takeoff, edge reinforcements, uh, if you need it, and by doing it, you can add yeah, quality, and you can decide the anchorage. I think 200 is gonna be okay, and whether you're gonna cut the mesh in the element or not, right? So you can do it from here, and I'm gonna add some openings now. Some warnings here for a family. Revit comes with it, but let's see. Did I press on escape? Yeah, I think so. So I'm just gonna activate the command again. Draw opening command. Window hole, okay. It remembers my settings. Yeah, there are some warnings, but I think I'll be able to draw it anyway. So we don't use time on looking into it now. And I'm that privileged that I don't have any um, architectural or engineering plan behind. So I'm just going to place it on my facades just to demonstrate for you. The drawing out of the double wall opening, and yeah, Impact says that the weight has changed of the element. That's true. We have a recess and a now, so we need to update the lifts. And here it is. That's my openings in here. Gonna do a door, so it uh, looks a little bit better when we present the final outcome. I'm gonna do a door, and I'm gonna keep the settings. I'm just gonna make it 2 meter high, over 2 meter high. Say okay. And yeah, the insertion point is then the middle of the lower point. Can I do a door in here as well? Updates. Okay, we update also the weight of those two elements as now has changed. Let's see how it looks. What we've done is that we have inserted some window and doors. Take a look in here. If I probably make it shaded. No, I don't want to save now. So we have some end stops inserted. What we set when drawing it. Can I select this? This is the end stop, and here, yeah, here it says that's the end stop family, right? And it's adjusted to the geometry. Now it's not always that you get it right. Probably this lattice girder family you need to move a little bit, but that's why you have the smart edit lattice girders functionality that would just presented a couple of minutes ago. Here we have the door. Also, we have this in stops around. And do we have a reinforcement? If I go on front view, and probably I can go into wireframe. Yeah, we also have the reinforcement inserted with this 200 mm anchorage. So if you do a reinforcement and end stop, do it already in the draw opening command. It's very smart, and it's customized to double walls. The last thing I want to mention when doing this double wall part is that we have actually opened for user-defined lattice girders. If you go into this lattice girders, here is where we define components, and it's say you want to make a new lattice girder. You have the possibility to say user define, and you can load your own family. Impact is almost all around the world now. We have I know there's different companies delivering components for double wall design. That's why we have chosen to open for user-defined lattice girders, and all the technical behind this development, or the technical information, you can go and find in this article in Wiki. If you go into Impact Wiki and change notes, impact for Revit, and you go into Q1 release, is the article where we also mention the parameters that we need in the family in order to get successful into drawing the lattice girders with the double wall and reform slab design. Okay, I think now we're ready to move into form slabs. I am going to draw some form slabs here on the top, and I'm going to add some holes, as we call recesses in form slab. So in order to draw form slabs, I think we're going to need to do it on a level 2, like this. If I move it on the left side. Okay, we can see what's going on here on the 3D view. I've already drawn some modular lines, which I hope they're gonna help me do the form slab, and I'm gonna activate the draw form slab command. So if I go into draw form slab command and I select my definition of the element, here's all the information that my definition consists. I can see that I have a mesh inside the element. I have some lattice girders and predefined spacing between. And what I need to do now is I want to select boundary. When selecting a boundary, I'm going to use the model lines that I've drawn in Revit. And here already I have the suggestion of how my form slab is going to be divided. You can always edit the insertion point by saying pick insertion. You can always have another direction if you need that. Just select direction. You can also get it in some degree, so it's it's runs diagonally here. There are pretty much a lot of possibilities for modeling. But I want to jump into edges, and here again a dynamic picture where you get some idea of how your edge, now it says straight, that's the name of the geometry I have predefined in my definition. So already in the definition you can decide how the edge looks like. That's really smart, and you can see here how it's going to be drawn. But it's going to be supported on this beam in here and on the double wall. So I'm going to say a 50 millimeter support length. I'm going to say next. So here I'm also going to need a 50 millimeter, and I'm going to need a 50 millimeter as I have there. Okay. And what is also good to know is that you can follow for parcel slabs. In this case, I have one parcel slab, which is pretty decent size of 2350. It's okay, but if it's like 8 millimeters or 10 millimeters, right, you can just say, I don't want to insert it, and you can just take it off. Okay, let's see how my form slabs are looking. If I go and say draw, Impact Revit is going to insert my form slabs for me. And let's see what we have in here. We actually have some, we call it lifting symbols, automatically inserted here on the form slab so that they can lift in the girders just on this point. This is definition define. We define the family that we use, this lattice girder, right? And we define the spacing. What I want to show you here is the support length. If you remember, I set it to 50 so that if your boundary goes here and you say support length of 50, it's actually going to go behind the boundary 50 millimeters so that it can be supported. That's why we call it support length. So that's a pretty smart feature when modeling foam slabs. I'm gonna do the other parts. So it looks a little bit symmetric. And yeah, I need to select the boundary, and what gives me a feeling of control is when I can select predefined model lines. I'm gonna go to fix the edges. It was 50 I wanted a support length, and 50 here, and 50 here. Otherwise, I think it looks okay. And I say insert. So, pretty important is to have a solid predefined definition for the impact elements. If you have it, then the drawing is pretty time consuming. Now we have the form slabs, and what we need to do now is we need to draw some holes and recesses, and yeah, here I have some uh, some model lines that we can use. I'm going to demonstrate different ways of drawing recesses. If you go into the form slab, you can say following menu, you can say draw hole. And here you have the possibility to select if you're going to do a hole or a filling as a removing material, adding material, or you want to cut or keep the mesh. You can add an end stop already here when you draw the cutout or the hole. And you can either draw or select objects. In this case, let's try to select the model line like this and press finish and OK. Let's see what we get. You can see it here in the corner. What we expect now is to get a hole in the foam slab, and not only that, but we also get the end stop in here. Yes, let's do some more holes. Basically the same settings. You can keep or cut the lattice girders, select objects. Let me select this ones. And I say, okay. Let's see how it looks. Some holes are already inserted. You can see here on the right. Yes. Here it is. We have the, is it better if we see it in shaded? Yeah. We have some holes that's circular. We have added um, end stop, and yeah, I think you got the idea of it. It's a really good tool when you go and do holes on your foam slab design. Now, as we're going further in time, I want to just demonstrate the end stop, the edge end stop. We have this functionality where you can say draw end stop, and you can just pick the edges of the element. So you say if you want to have end stop on all this side, you can just pick the edges of the elements. like this and say finish. You can choose the family, also offset from it, so you can just add it like this. That's easy it is. Nstuff's a pretty used component when you do form slab design, so it's important for me to show you this functionality. It's pretty easy. It's edge based, so you can go and do it on all edges here or just inside, also inside the elements, inside these slabs. Okay, but I think yeah, I think we should go further and do some linked elements before we save and we do the shop drawings. It's a yeah, uh, pretty good functionalities here for foam slabs. Go and explore them or go on Impact Wiki. I'm sure you'll find a lot of them useful. Now, we need to jump further to the linked elements, and linked elements you're gonna find here in the Impact tab, right? And what I want to demonstrate now is, first of all, if you need to draw a linked element, let's see here, you need to have a family, of course, behind. The linked element can be everything, and when I say everything, it's literally any family. Uh, our um, our requirement is that there is a family type that has the same name as the name of the definition impact. So here we have a straight stair definition of the linked element, and then there is a family type called the same, right? Not family, but family type. And I want to draw this straight stair. It looks like this. And what I'm going to do is I'm going to say draw linked element, right? Um, I think it was in common, yeah, and I used the straight stair. Um, you can have predefined override the parameters if you want in here. That's that we open for, and we're gonna insert the staircase. Let's see. There is some, yeah, I think it's best to make a section and just set it in place. Let's see here. If I do this section here, so I can better orientate myself how to set it up to the slab. If we go to the view, can we see here? Yeah, so first of all, we need to move it, right? That we all agree on. But also, we probably need to get the height of it. In this case, um, we can, oh, not that way, of course. We can go and set it to 4,000 or the length, but we can also change the height, 3,200. And why do I change it to that is because it's actually a pretty smart functionality for slabs. And if I go into 3D like here, I can demonstrate it. If you select a form slab, let me go to impact and say edit, um, edit form slab, and you select this one, press and finish, you can actually say show full thickness of the foam slab. Now, what we show here is the lattice girdle, but you can go and actually show the full thickness, which in this case is 200. So when this element is done, it's the 200 which is relevant. So that's why we're going to change the height of the stair to be this 3200. We're going to move it down here, and probably we're going to move it here like this. Let's see. Yeah, something like this. We've drawn the staircase, and let's see how it looks. And this is one example of a linked element, right? So I want to, just emphasize that linked elements, they can be anything. I've seen people draw dinosaur families as linked, right? It's fun, but anything in my definition, I had some. If you go here on the link definitions, you can see I had some steel beams and the balcony, some uh, circular walls, we call it. So it's a pretty open. If you can't define an element within the impact types that we've already have defined of element types, go and call it linked. Okay, but now we have one linked element here, and I think it's time to go and save our elements. What I'm going to do is first I'm going to save. We can save the slab elements, the form slab elements, sorry. Select them all, press escape, and now the elements are being saved in the database. Impact is going to automatically give them some element marks, and we are going to save all relevant components and reinforcement information in the database. After we save the elements, we are able to do a subdrawing, which we're going to demonstrate, and we're able to preview the elements in our center managing tool. That's the project manager when we talk about impact design. We also have this log where you can follow the saving of the elements, and impact is showing that the saving is going okay, and all the information is now saved in our impact database. Okay, we have the elements of the form slab saved, and now we go and save the double walls. We have a save double wall command, and I use the 3D as for me it's easiest to orientate. What you can also do actually is cross select. It's also easy. Probably less time taking. Go this way. Then I can do here. Select this one, and then we miss the cable walls in here. Pressing on escape, and impact is going to Impact is going to scan. We say save, and the saving starts. Okay, again, the same story here when we talk about double walls. We save each one of the components defined in the definition. And here's the smart part about impact, because once reinforcement, lifts, lattice girders are in the database, everything goes further to the shop drawing when we are doing that in impact. And let's see, we are now on the last double wall element, and we are soon ready to make a shop drawing. Yes, and the last element that we need to take a look at, that was the linked element. We say save linked elements. I'm sorry, save linked elements like this. Yes, press on escape, and there's one linked element I will need to save. That was the straight stair. Now, how do we make a shop drawing? Now the elements are saved, so you can actually go and make a shop drawing out of your elements. And let's take the form slab first. What you're going to do is say create shop drawings, and yeah, if you have prepared a shop drawing template, if you've worked on that and it's in your impact standard, then it's just you need to say, okay, I want to make a form slab shop drawing. You see here um, of this element, say finish, and impact is now automatically creating production drawing for you out of a predefined template. What is good to remember here is that anytime you do a change to a element, you can always resave it to the impact database and um, update the shop drawing. So it's what you get now, but if any changes get on your way to your final design, well, impact will be there to help you. So that's one example of a shop drawing, right? What we get in here, it's some views. It's up to you to decide how to organize them, how to place them up to your company standard. I would say we have some schedules, we have information about the project, some casting material schedules. This is all automatically generated by impact. So I will try just to make one of the double wall. That could be interesting, I guess. If we say create shop drawing, and this one this time is the double wall, right? So yeah, let's take this one with the wall and the door. So a double wall shop drawing is being created, and once you create the shop drawing, impact will also pop up with a suggestion to open it. Each shop drawing that is created now, it's actually a part of an assembly view. I'm going to scroll up and down in a while in the project browser when Impact is ready and show you where to find the shop drawings in the Impact Revit. It's you can see it's working on the back, and it's all the components that have been added. Are also good to mention that you have full control of how to measure and how to place your shop drawing. It's a huge list of available settings that you can do and customize. Um, so anything that you see in here in terms of dimensioning. You see the end stop here, though, where the reinforcement. It's up to you to decide whether it's on this view, you make another view out of it, or several sheets you can make in your shop drawing. So let's see where we are now. We are on the double wall. Here we are on double wall 05. It's called assembly, and we're looking at sheet 807. Okay, I think now we're ready to see our structure in Project Manager. If I open the Project Manager, I can update my model. And Project Manager is, as I mentioned already, the center tool of impact when doing precast design. It's not only the modeling that you can see in here, but also some precast transport planning, and uh, also planning for the transport for the casting of your elements. It's pretty smart tool. You can see all your elements are recorded. If you go and click on them, well, the information is there. A lot of parameters are saved and on place. You can, some of the previous webinars, I've also demonstrated that you can go, and if you have activated the cast planning model, you can just go and drag your elements, and if this is your casting tables, they're just there, and you go further with your design. So here it is. We have also the stairs drawn, and it's pretty smart tool when I say the central tool in Impact. So Impact Revit has the connection with it. Go and use it. Once you've saved your elements, they are visible in the database, and it's the project manager in reality. Okay, I think that was it for today. I would like to say thank you very much for everyone that has stayed with me here to the end. It was a pleasure presenting this double wall form slab and linked element webinar. I'm pretty happy with the results that we went through, and if you have any questions for one of the 3 webinars we did, just don't hesitate to contact us on our social media platforms. We are here to help you with your impact design. Thank you very much for staying with me today for this webinar session, and have a nice day, everyone.